Hi, I'm Katsumi, and today I'm going to talk about TextKit. I'm coming from Japan, and I work at RAM. Around text component, this ever happened to you? For example, the text isn't on the center, or the irregular line spacing, and so on. In this talk, I will show you how to render the text in the correct position. I'm going to be covering 4 major points today. First, I explain what determines the width, height, and line spaces of the text. It is important to be laid out on the text accurately to the aimed position. Second, very basic knowledge of typography because it is necessary to do that. Third, basic uses of TextKit, almost about NS attribute string. And finally, I show more advanced examples displaying rich text. So let's get started. TextKit has been introduced from iOS 7. What is TextKit? TextKit is a modern text layout rendering engine on iOS. It is built on top of core text and very well integrated with UIKit. Thanks to that, you can achieve an advanced text layout without using the low-level API directly, such as core text. TextKit is not a framework in the traditional sense. Instead, TextKit is the name of a set of enhancements to existing text displaying object and work with attributed string. So there is no anything special that uses the TextKit. Using UI label or TextView means using the TextKit. Okay, let's take a look displaying text that uses a UI label. Here are 2 UI labels. The same text, but fonts are different. Each font is the same size. However, the results quite different. As you may see, the latter label is taller than the former. Where do these differences come from? To understand that, I have to explain about the font metrics. Digital fonts contain data representing the metrics used for the displaying. In other words, the fonts know their sizes that are displayed. The baseline is the hypothetical line upon which characters rest. Some characters, such as J and G, have descendant that drops below the baseline. Definition of the baseline depends on the language, though at this time, it is described in the Roman text because the text case is based on it. The ascent is the distance from the top of the glyphs, the baseline. The descent is the distance from the baseline to the bottom. The leading is the recommended vertical distance from the bottom of the descendant to the top of next line in the multi-line settings. So far, I've explained what depends the text that on the area to be drawn. It greatly depends on the font. If the different fonts would be specified, the rendering result will change because the text is drawn by the font matrix. They are different for each font. So, can we know the size to be drawn without displaying it? We can achieve it by using the method of NSString or NS attribute string. It is bounding rate with size. that is a part of the enhancement of TextKit. This example is for the single line text. For multiple lines of text, uses line fragment origin option to pass uses line fragment options to the options. Sorry, excuse me. Uses line fragment origin. This screenshot is overlaying the label, the bounding rect. It shows that exactly match the bounding rect and the views. Okay, up next, let me touch on TextView. Here is a TextView that displays the same text and font, but it looks like a little larger than the UI label. Overlay bounding rect on the view, it's certainly larger. The same result even in the multiple lines. Why? Because UI TextView has margins by default. There are text content insert and line fragment padding. Also, UI TextView respects the font leading unlike UI label. Usually, it doesn't matter because from iOS 9, font leading is rarely used. In fact, San Francisco font, it is a new font from iOS 9, has 0 leading. Same for the other fonts, or have only very small values. One of the exceptions is CJK font. CJK font has large leading. And external custom fonts, if you use these fonts, they will lead to unexpected results due to the font leading. So, in order to know the exact size that the TextView to draw, you must remove the default margins. To remove text content inset, assign 0 insets to the text content inset property. Now, text content inset has been removed. To remove our line fragment padding, assign the 0 to text content dot line fragment padding property. Then, line fragment padding has also been removed. Finally, to ignore font leading, as explained earlier, leading might lead to an unintentional result. So, I recommend to always ignore the leading. Apple also said that leading is not appropriate in the UI text in the header file. I think Apple should document this. Anyway, to ignore the font leading, disable layout managers uses font leading property. Did it? It is now possible to know the exact size even in the text view. Just as a side note, when you specify uses font leading option, you can get a size including reading, like this. All right, this is the way to reset the margins of TextView. To accurately lay out in place aimed at, you need to know these behaviors. So far, I've shown how to get exact size in single-style text. Then, what about the multiple-style text? There's nothing special because even the text has multiple styles. It would be displayed on the same components such as your label, text views, and attribute string. In other words, all we have to do is construct a correct attribute strings. This is a simple example of attribute string. It changes font, color, and more wider spaces between the lines. Even as you specify what kind of styles, then you can get the correct result. To achieve the fixed spaces between each line, like this, set same values as font size to minimum and maximum line height. Then adjust the line spacing property. Why? Why there are two similar properties? Because for the multiple size fonts in the same paragraph, minimum line height keeps the line spacing. Maximum line height will do the opposite. Line spacing in the spacing between lines. Fast line head indent shift the start point to point of every fast line. Text alignment. Kerning is adjusting the spacing between characters. There are too many attributes to show, so after this, we will look at some advanced examples. This is the first example. There are much fonts, paragraphs in different styles, and breakpoint. It consists single view and attribute string. There's no any subviews, obviously. So defined font sizes, defined line spaces, inline images, tab stops and head indent. Another example is rendering mathematical formulas. I'm pretty sure displaying math is the most difficult challenge in text rendering, but TextKit can. The first example is the quadratic formula. Now we start from this. First, change to the math font. Shift the baseline of the radical symbol. Get down to A for the fractional. And move left using the kerning attribute. To superscript to the power. Superscript size is also defined by the font file. This font almost the same size in. So then scale the font manually. Scale method is like this. Using font descriptor, which is part of TextKit, you can apply CG affine transform to the font. In the same way, continue to adjust the layout. This is the character of the horizontal line, up the line, and move left. Same and same. Finally, the x and equal, excuse me. And finally, the x and equal center. Did it. Thank you. It's so beautiful, isn't it? It's the power of TextKit. Let's see the more complex example. But it is the same to do. So quickly, just see the change font, It just only repeats the same steps as well. Here, the vertical symbol needs twice height. So scale the font twice to y-axis, and baseline is up. The line also up. The line moved using kerning. All right, I did it. The examples are on GitHub. I'm happy that you see and play with it. In summary, the main points of my presentation were: no longer use Cortex directly. TextKit covers 99% use cases, I think. Carefully to choose fonts because TextView is based on font metrics. The most important is constructing attribute string correctly. That's all. So mastering attribute string means mastering TextKit. That's it. Thank you for listening.